Hi everyone. Today you're going to learn how to name ionic compounds and how to write formulas for different types of ionic compounds. You can refer to page 188 to 196 in your textbook for any extra help with this. And I would like you to copy down the sentences that are listed below on this page. Take a moment and look at these names of these ionic compounds. These are simple binary ionic compounds. They're made up of a metal with a nonmetal, or if you'd like, a positive ion with a negative ion. What do you notice about how their names are written? You should be beginning to see that the metal is written first, and it's written exactly as it is on the periodic table, and the nonmetals are written a little bit differently than their name on the periodic table. You can see that the ending has been changed to "ide." So you drop the entire ending of the name of the element, of the nonmetal, and change the ending to IDE. So you can see there's chloride, fluoride, oxide, oxygen becomes oxide, nitrogen becomes nitride. What do you think phosphorus would become? It's phosphide. How about sulfur? It's sulfide. So it's pretty simple. Metal first, nonmetal second, but the ending is changed to "ide." Now we're going to look at how to write chemical formulas. When you're writing the formula for an ionic compound, there is a series of steps that you should go through. So I'm going to show you how to write the formula for magnesium chloride. So this is an ionic compound. I know that it's ionic because I have a metal with a nonmetal. So the first step is to write the symbols for the two parts of the compound. I'm going to try using my pen feature here, but I don't actually have a pen, so it might get a little bit messy. So we're going to write the symbol for magnesium, Mg, and then the symbol for the chloride ion, which represents chlorine as a charged ion, is Cl. Then you're going to write what the charges would be on these ions. So if you look at the periodic table, you'll see that magnesium would have a charge of 2+. Chlorine has a charge of 1- as an ion. Now this is called the crisscross method, which I showed you earlier in the week, but I'm just going to remind you how to do this. So we take the numbers from the charges and we crisscross them down. So the numbers come down. Don't worry about the plus and minus sign. It's not really that important in writing a formula. You just have to make sure you're putting a positive ion with a negative ion. But the numbers come down. Now this 1 should be coming down, but one of the rules is you never write a 1 in. It's understood if there's no subscript next to a symbol that there is one atom of that ion. But the 2 has to come down next to the chloride ion. So the formula for the compound magnesium chloride is MgCl2. Try not to put a gap between the Mg and the Cl. I've got a little bit of a space here, but you want to write those symbols together. So I'll show you another one. Let's write the formula for the compound, let's see, sodium oxide. So again, we write the symbols. Sodium, its charge is a 1+. Oxide means oxygen. Oxygen has a charge of 2- as an ion. Crisscrossing, whoops, sorry, that was a little messy. We get sodium 2 oxide. Now I'm going to show you another one that has a different rule that applies to it. Let's say I'm putting magnesium again with oxygen. So I have the compound magnesium oxide. Mg, was a 2 plus, oxygen was a 2 minus. After crisscrossing, I get Mg2O2. However, with ionic compounds only, you must show your ions in their lowest possible combining ratio. And a 2 to 2 ratio is not in its lowest terms. So it's like math, you have to reduce these numbers. It's like reducing a fraction. So 2 2's divide into each other. And so this would reduce down to MgO. That is correct. Mg2O2 is not correct. You would do the same thing if you were crisscrossing 2 3's. If they were both 3's, they cancel each other out, you factor them down, and you would show no numbers in your formula. The next thing I want to show you is how to write chemical formulas and also how to write the names for ionic compounds that have those metals in them that have more than one charge. These are referred to as multivalent metals. If you look at the periodic table, all those transition metals in the middle of the periodic table, they don't follow those rules of electron configuration that we've been looking at. So we need to take into account that these metals could have more than one charge. There are some really common metals that we work with all the time in the chem labs that you're going to want to be familiar with. For example, iron. There are two forms of iron. There's iron 1 and iron 2. They have old names, ferrous and ferric, but their charges are 2 plus or Fe 3 plus. And it's just when you get into these bigger metals, their outer electrons can be in different places. They can be in different orbitals depending on the form of that metal. So iron could be iron 2 or iron 3, and that refers to its charge. So you want to really pay attention to the name of the compound. If the compound were named iron 3, and we use Roman numerals to show which version of the ion it is, so you're going to want to know your Roman numerals from 1 to 5 should be fine. So we have iron 3 oxide. So to write this formula, we're going to use the fact that we have iron 3, and that tells me which charge to use. And remember, oxide was oxygen with its 2 charge. And after crisscrossing, we end up with Fe2O3. So that's the formula for iron 3 oxide. So it's really not any harder. You just have to pay attention to those Roman numerals. You don't even have to look at the periodic table to find out what the charge would be if you have a Roman numeral. You just use that for your charge. It's a little bit trickier when you're going backwards from a formula to writing the name, because in that case you need to figure out which of the 2 ions you have. So I'm going to show you how to do one of those next. So let's say we have a compound called, if you have the formula CuCl. Well, you can see that you have copper in here. Cu is copper and Cl is chlorine. Copper is one of these multivalent metals. And if you look at the periodic table, copper could be a 1 plus, or it could have a 2 plus charge. So there are 2 versions of copper. There's copper 1 and copper 2. Chlorine, sorry, a little messy. Chlorine has a 1 charge, always. That never changes. So if we look back at the formula, what we have is CuCl. There are no subscripts, there are no numbers in that formula. Well, I know that there was a 1 on that chlorine, and it crisscrossed down here. Well, what came down next to the chloride ion? There's nothing there in the formula, so there had to have been a 1 as well. So that tells me that the version of copper that I'm working with here is copper 1. So when I write this name, I have to put that in. Copper 1, chloride. You must show which form of copper it is. You have to put that Roman numeral in there. You have to indicate, was that copper 1 or was that copper 2? in that formula. And so it's a little bit of detective work. You kind of have to work backwards. It's a little bit like puzzle solving. So on the next slide, I'll show you one a little bit harder. So here's an ionic compound with a multivalent metal, SN. SN is tin. Take a look at the periodic table. See if you can find tin, SN. It comes from the old Latin names of stannus and stannic. Not sure what that means. But anyways, we have tin oxide. Now tin is a multivalent metal, so we need to figure out, based on this formula, which version of tin is involved in this. Is it tin 2 or is it tin 4? So tin can have a 2 plus charge or a 4 plus charge. Remember, oxygen had a 2 charge. So after crisscrossing, we should have a 2 next to tin because the 2 from oxygen is coming down. But notice in our formula up here, we do not have a 2 next to tin. So what does that tell me? It tells me that there had to have been a number over next to oxygen that would have allowed that 2 to reduce or cancel out. And if we look back at tin, our options are a 2 or a 4 crisscrossing. Well, if a 2 had crisscrossed down, we would have had SN2O2. And what does that cancel out to? That becomes SNO. It's not snow, by the way. SNO. And that's not what we have up above. We have SNO2. So it had to have been the 4 that crisscrossed down because that reduces to our SNO2. The 2 and the 4 reduce down to a 1 and a 2 in the formula. Remember, you have to show your ions in their lowest possible combining ratio for ionic compounds. So how do we write the name for this? Well, it would be tin, and because it was the 4 that crisscrossed down, we have to write Roman numeral 4, which is IV, oxide. So that's just about the hardest one that you would see in this set of problems that you're going to work on today.